Reasoning from the first principles is to break down complicated problems into basic elements and then reassemble them from the ground up. EVM, the Ethereum Virtual Machine, is the first principle to understand how Ethereum works. Ethereum can be viewed as a transaction-based data machine or world computer. EVM is just like the CPU of it. It processes all the changes to the present state of the machine and gets the result of the next state. The EVM is single-threaded, which means that it executes the instructions in a single sequence, and this is why all the nodes run the EVM on their own machine would get the same next state. So what is the connection between the smart contract code and the EVM? The EVM cannot understand the smart contract code directly, it only understands bytecodes. Each time we deploy our contract, the smart contract will be compiled down to the bytecodes, and these bytecodes will be run on EVMs of nodes all over the world when certain transaction call this smart contract. The EVM is stack-based VMs. It operates on data stored in a stacked data structure, that is, it follows last in first out principles. Let's see how it works. The program counter will be set by the instructions fetched from the stack, and then it will index certain bytecode and execute the instruction. And loop will go on with new instructions fetched from the stack. This process will continue till the stack is emptied or return is called, or when a transaction is reverted due to lack of gas, stack overflows, or other problems. It would be a bit dry if it only talked about a theory. Let's get our hands dirty by playing the EVM puzzles. EVM Puzzles is a project developed by Franco Victorio. If you are learning how the EVM works, you cannot miss this. Before starting, I will introduce a useful tool called EVM Codes. It is an interactive reference to the EVM opcodes. You can find a description of all the opcodes here, and you can also play it on the playground. Let's start solve the puzzle 1. First, we have the call value, and next is the jump instruction. The call value is the value of the current call in way. And the jump instruction will alter the program counter, which means that it will directly jump to the jump destination. First, we'll push the call value into the stack, and then the jump instruction will pop one value from the stack and jump to various states. In order to jump to the jump destination, we have to make our call value equals to 8. That is the answer. Let's just have a try. Enter 8. Well done, the puzzle has solved. Let's start solve the second puzzle. We have two instructions new to us. The first one is the code size. That is the byte size of the code. The second one is the sub. You pop two values from the stack and do the subtraction. Let's go around the opcodes. First, the call value has been pushed to the stack, and then the code size. The code size minus the call value is pushed back to the stack, and if we want our jump instruction jump to the jump destination, we have to make the code size minus call value equals 6. As the code size is composed of opcodes and each opcode is 1 byte, so the code size of our code is 10. We can get that the call value should be 4. We continue our playing, and the 4, and it works. Now we try to solve the puzzle 3. There is one instruction new to us, the call data size, that is a byte size of the call data. It is quite similar to the puzzle 1 and puzzle 2. We have to make our call data size equals to 4 so that our jump can jump to the jump destination. This is an example call data. Let's start playing. That's correct. Let's start solve the puzzle 4. There is one instruction new to us, the exclusive OR. You pop two values from the stack and perform the exclusive OR operation. Just like the puzzles before, in order to jump to the jump destination, we have to make our code size exclusive OR call value equals 10. As the code size is 12, the call value should be 6. Continue play the puzzle, enter 6, and we make it. Let's go with the puzzle 5. We have several instructions new to us. The first is the duplicate. You duplicate the first value and push to the first position. And then is the multiply. You do the multiply operation. The push to will place 2 bytes item on a stack, and the equal will pop 2 values from the stack and compare them. The equal will push 1 to the stack and otherwise will push 0. The push 1 place 1 byte item on the stack. After this instruction, we get to know that at the index 7 in the stack, the first value is C and the second value is a Boolean flag. It will be 1 if the core value multiplied by core value equals to 0100 in hexadecimal. Here's a new instruction called jump I. It will pop 2 values from the stack. The first value will be the new program counter to jump to. The second is the Boolean flag evaluate whether you must jump or not. In order for the jump I jump to the jump destination, we need to make the Boolean flag to be 1. That is, to make our core value equals to 16. Have a try. The puzzle is solved. This is the first part of the EVM puzzles, and the next 5 puzzles will be solved in the next video. If you like this video, please hit the like button and subscribe me. It will help me a lot.